Ready to start. All right, like I mentioned, my name is Sharath Kanniyappan. I'm a controls engineering lead at Honeywell. And like I was mentioning, I deal with electromechanical systems. We provide conveyor solutions to all our major e-commerce players, major post and parcel service customers, and we provide mechanical, electrical designs, manufacturing, controls, and warehouse management systems, which is a software that sits above all the controls and interacts with the outer world. So um, basically a one-stop shop for your warehouse solutions. All right, I'm here today to talk about a recent case study, which we are in the final steps of implementing for a couple of our customers. And there are a couple of certain surprises that we ourselves learned as a company trying to implement this digital twin. Now, let's begin with what a digital twin is. We've always had 3D models of systems, animations, and simulations and emulations, but what sets digital twins apart? So in order for a 3D system to become a 3D model or, um, you know, which we use, build using 3D building software, AutoCAD, for example, is it needs to talk to your physical system, get feedback, and at the same time, it should be able to decouple from your physical system and use the model that you developed to run scenarios, to run edge cases, basically collect data that in turn can be used for greater purposes. So that is in essence is what digital twin is. Now, from the outset, you can see, or you can say digital twin is a great way to visualize your system, great way to collect data. You're collecting data at the same time you're looking at what's physically happening in the system and all that, but who's ready to pay for that? The customers certainly are not, because they already have a working physical system. They don't really see the value of why they want to get into a digital twin and use that to you know simulate or emulate different situations. They have the data set. They can just use the data set to manipulate it or find solutions through without a digital twin. So that's where, um, for us as a company, the challenge was. So we were looking at ways to how we can pitch this better. So we started looking inside, see what our digital twin development process is. So at the end of the day, your digital twin is an exact replica of a 3D, or exact 3D replica of your system that is used for data collection, right? So we looked at our process. So if you look at our process of how our project flows, you're going to have the sales and concept and estimating phase, where we will create a 3D model of the concept. For example, in a warehouse, you have people who pick boxes or pick products, and then there's a separate area to pack these boxes, and then it conveys to a different part of the building where we ship it onto trucks. So in our initial concepting phase, we come up with, okay, you're going to need you're going to need 4 packing areas, 4 shipping areas, 4 uh, you know picking zones. So in that phase, we do a simulation where we just have a concept, we just run it through the 3D model, we just show the customers, okay, this is the throughput, you're going to get 1,000 boxes through this area in 1 hour, because the conveyor speeds are set in such way. So it's purely based on conveyor speed and conveyor length at that point. And then comes the emulation phase, which we, again, call it emulation because we use feedback from the actual programs that we build to control these conveyors. At this stage, we have a emulation environment, or a 3D environment, where we write the code for our controllers and we use it in a virtual space. We download it to a virtual controller, and then we run these models based on the code that we wrote, which is an engineered solution which we set in front of our customers. Now, talking about value, this is where we figured out, okay, this is the place that we can create value for both us and the customers, show them, okay, the emulation model shows such and such. So you need to increase your speed here, you need to decrease your speed here, you need to add a sensor here kind of information. So we were able to provide that value. And on top of that, we are not building anything new. We already have a 3D system. We already have programs that we anyway have to write to deploy to the site. All we need to do is add a virtual environment uh, that can marry these together, which is where uh, we went out to the market and saw which is our best option to start using that. So in essence, we were able to fix a lot of troubleshooting issues and on-site deployment functional checks, fixing bugs. All these were done in the office during emulation phase. So that gave us a lot of value in terms of development and also interacting with our customers and telling them, if you need to make a change, you need to do it right now, because making physical changes to the system once it's installed is a tedious task. So, that kind of started the conversation with our customers, telling them, okay, these are things that you can do using emulation, and these are things that you can get ahead of yourself before we install the physical system. Now, this is one of the cases that we presented. This was for a e-commerce customer down in North Vegas, where you have conveyor lines coming from 10 different parts of the system merging into one line, which will eventually feed another system. Now, this is an emulation model where the program, the PLC or the controller, we call it the programmable logic controllers, which are industrial controllers used to control these conveyors. So this virtual model is running on the feedback of an actual PLC code that we eventually deployed 2 weeks after. So at this stage, we were able to troubleshoot. You can see the scale of the system. It's 10 different lanes merging into one. Trying to troubleshoot it on site is going to take close to 2 weeks, 3 weeks, whereas in your office, you can just emulate it and even run it in 2x speed and make it go faster to get a faster response time. And this is for another post and parcel customer. So you can see this is a spawn point for the boxes. So the feedback here, again, uh, the sensors that are supposed to be in the system, the motors that are supposed to be in system, everything is already embedded in this model. Just the boxes get spawned. That's the missing piece. That's the software that we went outside, got from providers that are outside of Honeywell. And it just spawned the boxes, and the boxes behave exactly the way it's supposed to based on the friction of the belt, the sensor input, and this is a sortation system where you can see the boxes get sorted here, get diverted to a different part of the system. So having this as our basis for emulation created value for both us as integrators and for our customers, so that the next stage where we get to the digital twin, so we deployed for 5 to 6 months on site after we write the code. Once we've done deploying it, uh, we now have an as-built drawing or as-built 3D model of the system, because there are always minor changes here and there when you deploy something to site, and if something's in work for 6 months, there are certain changes that you expect. So considering all that, by the end of all the deployment, now you have a solid engineered system with all the 3D models already developed. All you need to do is match it to the as-built and as-installed system. And now on your hands, you have a 3D model that is ready to be a digital twin. So, and this is the architecture. And as you can see, all you need to do is connect your controllers to this 3D model, get all the data that you need for whatever scenarios you want, or get all the data that you need from site, and decouple your physical controller connections from the 3D model and emulate or run scenarios that you want to. And that way you bring value to your lifecycle support teams and also your customers who want to run different situations without troubling the system. All right. So that in a sense is what I was talking about all along. And that's it. Yeah, I had to literally run through that with all the time crunch and all the technical issues. I think we're good. Yes.
Just a question, when you're operating the scenarios, the what